the purpose of this lecture is to introduce us to R programming, and then a number of us may have already started using R before, or we are now about to use R. So the purpose of this lecture is to introduce us to what R programming is, and then what it can be used for. And then we will have some few demonstrations as to what we can use R for. So, as rightly mentioned, my name is Isaac Kwame Badu, and I hold an MPhil in Entomology. I'm currently within the University of Cape Coast, serving as a curator, which is a voluntary role. So I started using R somewhere 2018, 2019, when I took a course in biostatistics. And then R was introduced to us as one of the softwares that can help us in performing our data analysis. But then I stopped using it for some time because it was a little bit challenging at the beginning. But going forward, during my master's, I resolved to use R for my analysis. And then also because of the nature of the analysis that I was supposed to do for my MPhil studies, I needed a software that is better suited for that kind of analysis. So it led me to learn so much about R. And then majority of the things that I know and then I'll share with you today were self-taught. I didn't really have a formal class to sit in to learn about R. Most of the things I know and can do were self-taught. So for those of us that are interested in learning this is as a way of encouragement to make you know that you can learn R on your own without having any guide. But of course, once someone starts you up, it's easier to pick it up from there. So please, I hope you can see my screen. Sorry. Hello.
Yeah, perfect.
You can see. Okay, that's okay. Yeah. So the presentation outline will go through. So we'll talk about what the R language is, and then we'll also try to understand why we should even use R in the first place. Then I'll expose you to one or two things about using R. Then we'll have a few demonstrations, and then, of course, I'll leave room for some questions and answers at the end of the presentation. So to begin with, one may ask, what is R? Or if you've heard R before, what is it? Is it just one of the alphabets, or what is unique about the letter R? So R is a programming language. It's a programming language that was developed some decades ago, and then it was developed mainly for statistical computations and then for graphics. So there are several programming languages that have been developed for communicating with the computer or for various functions on the computer. This include the Python, the C++, the JavaScript, HTML, and then so many other languages that have been developed. Each of these languages have their own purpose for which they were developed. So if you take Python, for instance, the users of Python may use it for app development, software development, some even for data analysis, machine learning, and all of that. C++, JavaScript, HTML have some functions when it comes to web development, and then also software development and all of that. So, but for R, what is unique about it is that it was developed mainly for statistical computations. So it came in as a language that would help us to perform various statistical computations and also to give very good graphics or to visualize our data. So because of this idea behind the development of R, it is mainly applied in academic research. So a number of research institutions apply R in their statistical analysis. But in recent times, we have seen a shift from its use in just academic institutions to several other fields. So in the health sector, where they usually have to deal with epidemiology of diseases, they need to make some computations about some aspects of health, of global health, of humans, and all of that. They have began to employ R in the health industry. If you take the finance industry too, R has recently been employed to sort of assist in their visualizations. You know, mostly these finance guys want to do some projections as to maybe some profits they'll be making over a 10-year period, over a 20-year period, make projections about the success of their businesses, and even analyze data concerning their customer base and some other issues that would be relevant for them in the finance sector. And then a number of them have begun using R for these functions. So mainly roles that involve data and data processing have begun to rely on R as the main tool for such statistical computations or for such functions. But then why R? R is important for you if you are interested in working with data. No matter the kind of role you want to fit in, being whether you want to be an academic researcher, whether you want to be a data scientist, whether you want to be a data analyst, or any other role that has to deal with data, processing of data and analysis of data, you certainly need R. Majority of us may be familiar with other data processing softwares like the SPSS, Excel, Stata, Minitab, whereas these softwares are good. They have certain limitations in terms of their functionality. And then R offers a very good platform that serves as an improvement over all of these softwares that are often used for data analysis. In the use of these software, sometimes we find ourselves moving from one software to the other. Sometimes you have to do your manipulations in Excel, then you transfer the data to SPSS, or you do the coding in Excel, transfer to SPSS or to Stata to Minitab before you can do all of these analysis. But then R offers a common platform for all of these, such that it is easy to work in R without having to move from one software to the other. You may need Excel to collect your data, for instance, but then once you import the data into R and then begin to work in it in R, you wouldn't need any other software to work in conjunction with R. Also, majority of these data roles that are coming up in our time, these data scientist roles, data analyst roles, require the use of R mostly. So if you look at a number of job applications or job openings that are floated around, sometimes these employers ask for people who are well-versed or who understand the basics of R. And then because R is one of the tools that has become very useful for data analysis. Yes. So the functionality of R is very wide. It helps in performing basic analysis. So your descriptive analysis, if you have to calculate your means, your standard deviations, your variances, you need to find the mode and all of those things. R can help you do that very easily. If you need to visualize your data, for instance, you want to plot graphs, you want to show some trends in your graphs and all of that, R offers a very good tool for producing a wide range of graphs that is very useful for both academic research and then also for the industry. Also for inferential statistics, for those of us that have to make inferences from our data. You want to conduct, say, an ANOVA, analysis of variance. You want to conduct a t-test. You want to do some modeling, for instance.
Hello, Ike. Sorry to interrupt. Yeah. Please, are you moving your slides or you are still on the phase one?
I am on YR. That's the title of the slide I am on now.
Okay, I think the slide is still on the first one since the introduction. Yes. Okay, it's now moving.
Let me put in display mode and see. Has it moved? Hello, has it moved? Hello. Hello.
Yeah. Slide number 4.
I switched from one slide to the other. Did it move?
No, it's still at number 4.
Still at number 4.
Yeah.
Just hold on a bit. Has it moved now?
No, still at number 4.
Still at number 4. Wow. Then perhaps
I
have to use.
Or you can use the presenter mode and then just stay.
I'm trying to use the presenter mode, but that is not working. So perhaps I have to use this. Just okay. Okay. Just a minute. I'm not so familiar with Google Meet, so
it's fine.
I mostly use Zoom and Teams. So I want to be able to navigate through. Okay. I guess I have to use this. I have to use
maybe which one? You have to click on it too.
I mean, I don't have to use the presenter mode. I just have to use the PowerPoint as it is. I think this is
it's moving.
This is
now.
okay, right?
All right. Yeah. Or you can just display it like a slideshow and be.
Yes.
Is that okay?
No, when I display as a slideshow, you don't see. That's when you don't see the movement.
Okay. All right.
Yeah. So I think this is okay, right?
Yeah.
I'm moving. You can see the movement.
Yes. Yeah.
Okay. Okay. I think I'll use this instead.
All right. Thank you.
Yeah. Thank you too. Yes. So sorry for the interruption. Let's continue. So, like I was saying, R can be used for a number of functions. If you want to do your inferential statistics, for instance, R can easily help you do that. For those of us that are interested in statistical modeling, trying to model relationships between variables, model effects of other variables on some responses and all of that, R can help you do that effectively. Also, for those that may be interested in machine learning models, for instance, R is very useful for that. In addition to Python, R can also help you to be able to effectively perform machine learning models. Yeah. So one other reason for which you should use R is that it is easy to learn. It is easy to learn. It is very easy to learn. In the beginning, I mentioned that for me, for instance, most of the things that I know, I had to learn it myself. And then there are a lot of resources available to make learning of R easier. So it's not something difficult that you would struggle with. You will certainly find it easy to learn. But one trick about using R is that you need to have a good command over statistics, because most of the functionalities in R have been developed to perform some analysis on data. So if you understand statistics and then know what kind of analysis you want to run on the data, and then why you have to run those analysis, if you know the assumptions behind those analysis and all of that, it helps you to be able to use R effectively. Remember, R is only a tool. R doesn't understand, for instance, what ANOVA is. You would have to know that ANOVA is used for comparing three groups. It's used for making comparisons between three groups. Then you can use ANOVA to analyze your data in R. Okay. So you knowing statistics is a good basis for you to easily learn and then adapt to the R language. One other thing about R is that it's also a very easy language. It's an interpreted language. So you don't have to struggle to sort of be a very deep person when it comes to coding. You just have to know the basics. You just have to know the basics. And then once you are able to interpret the language, you can always modify codes to perform the various functions that you want to perform. Also, it doesn't require you to build your own functions. There are several inbuilt functions in R, and you just have to know the function that you would need for what you want to do, call that function, and then use that function to perform what you want to do in R. So it's very easy to learn. And in addition to the structure of the language, making it easier, there are so many online resources that will help you to easily learn R. So, like I said, it's a very popular software that is used not just in academic research, but even in industry, in the finance, in the health, in so many other fields. So there are a lot of people that are using R day in and day out. And then, luckily enough, these people are not stingy with their knowledge. So you have people building knowledge on R every day online. So people are creating blogs on R, people are tweeting on R, people are creating YouTube videos on R. So there is a lot of information on R that will help you to be able to learn it and then do whatever that you want to do with R. So YouTube, for instance, is one of the sources that you can also always go there. You just type in, if you are to type in introduction to R, for instance, as we are having here today, there are so many videos that have been developed on introductory lectures as these. Also on Stack Overflow, there's a wide community of R users that are always, people ask questions there, and then they are always providing answers to these questions. So there are so many resources that you can always go for in R. The R software itself also has inbuilt help functions that would enable you perform the various tasks that you want to do in R. So if you are stuck, you just have to search for what you want to do in R, and then it will give you the output. Yes. So let me just demonstrate how to search, for instance, in the R software, and then we proceed. So I hope you can see my R console screen. Please, can you? Hello?
Yeah. At the lower right. Yeah.
Yes. Okay. So this is R Studio. Is just one of the softwares that uses the R language. So let's say, for instance, we want to perform the mean of a set of numbers in R, but then we want to know whether R understands mean or not. Initially I said that R has a lot of functions that have been built in the language. So you only have to search to identify whether that function is already available, so that you just apply that function. So with a question mark, and then let me increase the screen. With a question mark and then mean, for instance, when you enter, it gives you what R understands this to be. So you have an arithmetic mean.
Can you maximize it? It seems it's so small for us to see.
It's still so small.
Yeah.
Yes. Is this better? Is this better? Yeah. So
no changes so far.
You said?
I believe you are on the R console, right?
Yes, I'm on the R console.
It's still just a small window on the slides.
No. I'm sharing a different screen now.
Oh, okay. No, we can see that.
You can't see that screen.
Yeah.
Okay, just a minute. You can see now.
Yeah, it's now visible.
I think this. So yes, so a simple question mark and mean, for instance, gives you this output in R. So it tells you how R understands this. So the description is giving us the generic function for the trimmed arithmetic mean, and then it will tell you how to use it. So you have mean, and then X, where you input your data, and then some other argument, which we'll get into later, and then it will give you the output. So it defines all of these arguments for you, what X is, what the trim is, what the NA.rm, and all of those in R. So even within the R software, there are inbuilt search or help tools that will enable you effectively learn R. Yes. So let's continue. So why R? We are still on why we should use R. R is one other advantage of R is that you can use it on various platforms. So R is not only available for Windows, For those of us that use MacBooks, you can use R on it. Those that use Linux, you can use R. Also, R has the ability to communicate with the other languages. So you can easily communicate with Python, you can communicate with Java, you can communicate with HTML, and so many other programming languages. So it makes it easier to use. So for some tasks that you'll be doing when you decide to learn R or when you advance in R, if you have to switch between R and Python, for instance, you don't have to change your codes or change the structure of your codes. R has that ability to communicate easily with other programming languages. One advantage of R2 is that you are not limited in your functionality. You can write your own functions in R. Aside all the functions that have been inbuilt in R, you can easily write your own function. So let's say you want to perform a task in R, and then you are not finding that function. You can develop your own function, which also helps to extend the abilities of R. So that's also one of the benefits for which you have to use R, or why R is recommended for data analysis. The most important advantage of R is that it is absolutely free. Everything about R is free, from the software to information on the web. Everything is free. There's no need for subscription. You don't have to belong to any institution to have access to the software. Everything is totally available, and then it's available for everyone of from every part of the world. Yes, so that's also one of the key reasons for which some of us use R. For those of us that would want to learn programming in general, R is very good as a first language. Other languages may be quite difficult to understand, but R is quite simple. So once you learn R and then you understand the R language, it is easy to build upon the R language to move to other languages. Yes, so these are some of the reasons why R. Certainly, R is not entirely perfect. There are one or two challenges that you may encounter in your use of R. So because it is a programming language, it requires that you appreciate the concept of syntax. So there is the need to understand how codes are written, and then the proper arrangement of these codes. So the various functions that you'll be using and the arguments that are contained in these functions, you have to understand how they are properly arranged. And then that is what will help you to be able to use R. So it takes a little bit of effort to understand this structure. But trust me, it doesn't take so much time to be able to get this and then begin to use R. Also, it can be challenging at the beginning, especially when you enter a code and then you start getting errors and all of that. It can be quite challenging. It can be quite challenging, but the more you persist, that is when you are able to gain the experience. So initially, I mentioned that I started some years back, paused, and then picked it up again. But then when I picked it up, initially, I found one or two challenges, but the more I kept on using, the more easier it became. So don't be discouraged when you start using R and then you encounter errors. So you run something, you see an error, you run something, you see an error. The beauty is that once you're able to figure out that error and then work on that error, the next time you wouldn't make that same mistake again. Also, in some of its applications, there are some limitations that R has. So in machine learning models, for instance, R isn't so good for that, but Python is more appropriate for those that want to go so much into machine learning models. So that is that. Yes. So now we know why we should use R, and we've come to appreciate some functionalities of R. But before we can even go ahead to use R, we need to get the software. So like I initially mentioned, R is free online, and then for you can search for you can input these links in your address bar in Google, and then you'll be led to the site in any of your web browsers. Yes, and you'll be led to the site where you can download R and then R Studio. So the original language that was developed was R, but then over time, the base R was limited in some of its functionality. So R Studio was developed as an interface that helps to use R, that makes it easy to use R. So you would need these two if you want to work with R. You can have R alone, as is indicated, the blue R with the hash oval sign around it. You can have R alone and use that perfectly, which is also fine. But R Studio requires that you have R before you can use. Without R, you can't use R Studio, because R Studio is only an interface. That's so the R is what works behind in the background, but then R Studio is just an interface that you'll be working in. So I would show you these. I'll show you how the windows are, and then we will see how the differences between R and then R Studio. Sorry. Yes, so this is the base R. In the base R, once you open, you'll be given this introductory message, and then these instructions: this to open a script, this to load workspace, this to save, and all of that. So this is how base R interface looks like. But what I opened initially was the R Studio. So this is how the R Studio looks like. So once you open, you would have a console here. It usually has four interfaces. So you have the top part, which is likely to be missing once you open R Studio. And then you have a bottom part with a console. And then the top right corner, you would have an environment, history, connections, and tutorial. And then below that, you have files, plots, packages, help, viewer, presentation. So R Studio gives a more nicer background or feature than the base R. In R Studio 2, you are able to, it gives you suggestions. It gives you suggestions. So for instance, when I start to type mean, for instance, it gives me various mean functions that are within R. It gives you suggestions, but then you wouldn't have this in base R. It also gives you color codes that helps you to differentiate between whether you are inputting a comment, whether you are inputting a function, or even an output of a result. So R Studio is, I would recommend you to work in R Studio more than working in R. More than working in R. So we'll go ahead to understand some few things that matter when it comes to the use of R. So please, I hope you can see this screen.
Yeah, it's visible.
Okay. Yes. So some tips or rules in the use of R. So spacing does not matter in R. Spacing does not matter in R. So you can choose to space out your codes, compress them anyhow you want, and then you would still have the same outputs or the same results. So for instance, if I want to perform a simple addition in R, if I type in my console, as you can see me do, if I type 2 plus 3, for instance, and press enter, it gives you an output as 5. If I space out this code, it will still give me the same output. So spacing is not important in R. Use spacing based on how visible you want your code to be. So that is how to use spacing. But aside that, spacing doesn't matter, except when you are using names of variables. In that case, spacing will be important to R. We'll get into that later. R is also case sensitive. So spelling a word with a caps as the first letter is not the same as spelling a word with a small letter. So R is case sensitive. So for example, so I have capital A, and I want to say R should store this A value as 3. When I enter this, and then I want to call back A, I type A, and then R tells me that A is 3, because initially I have told R that store A as 3, or assign 3 to A. But if I type small a and then enter, it gives me an error that the object A is not found, indicating that R cannot recognize that small a and capital A are the same thing. So R is case sensitive. So you should be careful when you are working with R. R cannot recognize typos. So if you are writing a code and then you make a typographical error in terms of spelling, R cannot recognize, and then it will throw in an error as your output. So every code that you write must be checked again before you write. But then one good thing about R is that it can recognize unfinished codes. So where you are writing a code and then you don't finish, R will prompt you that you have not finished writing the code. So for instance, I want to do both addition and subtraction at the same time. So I input 2 plus 3, then minus. I want to subtract another number, but I forgot to input that number. And then I press enter to run my code. It didn't give me an error, but it gave me plus, indicating that I haven't finished writing my code. So I should input a number there. If I ignore this and press plus again, it will still give me a plus sign until I input a number to complete the code. That is when it will give me an output. So R is able to recognize unfinished codes, and then that is one of the beauties of the functionality of R. Because R was developed mainly for statistics and for computations, it can easily be used as a calculator. So every operation that you want to perform in R, it's possible to do in R. So you can do addition in R, you can do subtraction in R, you can do multiplication, division, you can find the powers of numbers, you can find the log of numbers, you can find the square roots, you can find the logarithm of numbers, and all of that. These are all built in R. So it is easy to perform these functions. I've already shown you how to do addition, subtraction in R. So for multiplication, you need the multiplication sign, which is the star in R. So for instance, 4 multiplied by 5 will give you an output of 20. So R recognizes star as the multiplication sign. For division, you need the slash sign. So 20 divided by 2. So with a slash sign, you do division in R, and then you can have this output here as 10. You can also have powers. So you can find the powers of numbers in R, and then there are 2 ways to do that. Either you are using the inverted greater than sign or 2 stars. So let's say 4 raised to the power 2, you'll find this symbol mostly on, on 6. So shift with 6 will give you the symbol. 4 raised to the power 2 will give you the output. You can also use 4 double star 2, and then this will also give you the same output. So R can perform basic operations for you. As your code R also has inbuilt functions that will allow you to perform some of the tasks you want to perform. So for instance, there's an inbuilt function for logarithm, for instance, and then the log of any number will return an output for you. The log of any number will return. So R has that inbuilt function as log. So you just have to type log, and then you input your number, and then this will be given to you. The pi of a circle, 22/7. This value is also recognized by R, or inbuilt in R, as pi. So if I type pi, for instance, and press enter, you have the value for pi, which is 3.14. So if I want to perform any computations on a circle, for instance, I want to find the area of a circle with a radius of 5 centimeters. I only have to type the pi, then the radius is 5 centimeters times 5 squared. And then this will give me the output for the area of the circle. So R also has some of these inbuilt functionalities that helps it to be able to be used perfectly for computations. There is also your cos, your sine, your tangent of angles, trig. When it comes to trig, these are very helpful. All of these are inbuilt in R. So the sine of any value, for instance, will return a value, a number for you. You can find the cos, the cosine. You can find the tangent, an angle. All of these can be done in R. R has these inbuilt functions already. So you don't have to program R to understand what cosine is, or what sine is, or what tangent is. It already knows these things in its system. So these are some of the usefulness of R. If you can see, so far I have been typing here in my console. So you can see a console terminal background job. In this console, you can type here, and then you receive your outputs. But one advantage of R is that every analysis you perform can be stored and then later repeated. So R has you are able to build a script, something called a script. This is just like any text editor, like your Microsoft Word or your Notepad, just like any text editor, where you can input your codes and then run it to see your output, and then store these codes for later use. So this is what we call a script. So if you look in the left side of the Windows, I have the top part as a script and then the bottom part as my console. So in this script, I am able to write my codes here and then run them to see the outputs in my console. And then later I can close the script and then reopen it again at another time and then rerun all my analysis that I have done. You can also annotate in the script. You can make comments. Hash is used for making comments in R. So once you input hash in R, everything behind the hash symbol is recognized as a comment. So if you can see my script, for instance, I've used hash to indicate various comments that I would want to focus on for this lecture. And then R will not recognize this as a code. So if I'm to run this comment, for instance, it will skip all the comments and then go to my next code. It will not run all these comments. It will ignore everything behind the hash symbol. So that is one of the beauties of the R studio or the R language. Yes. You can also share your script to other people. So after this lecture, for instance, maybe if some of us who will be interested in learning R, you may need some scripts to start up, some scripts about some basic things you can do in R. I can easily share this to you, and you only have to pick it up and then edit to suit what you want to do, and then you run the codes, which makes working with R quite easier. Yes, and these scripts are also cross-platform, just as the R language is. So you don't need to create a different script if you are using a MacBook or Linux or whatever. You just have to. You can use the same script for all of these platforms, and then you'll be fine. So that is also one good feature about R. For most of the time, we often work with data that have been collected on the field, for instance, and then R helps us to be able to input this data into the R environment, and then we conduct our analysis. But then you can also generate your own data in R without having to create any data from elsewhere, which is also one of the so if you want to enter just let's say a list of numbers between 1 to 10, for instance, R simply allows you to be able to do that. So I just inputted a code for R to generate for me a list of numbers between 1 to 10, and then it gave me that output. So if you realize this time I'm typing in my script, and then once I type in my script, you can see the output in my console. I can rerun this code several times. I can close it, reopen, and then I'll rerun this code several times. So it gives you a permanent trace of everything that you've done in R. So you can generate data in R. This is generating data from 1 to 10. Let's say I want to generate data from 1 to 10, but I want R to space it by 2. So there's a code to be able to do that. So sequence of data, I tell generate from 1 to 10, and then separate by 2. And then this gives me the output. So gave me 13579. Yes. So R helps you to be able to generate data easily. Because this is just an introductory class, we wouldn't go too much into details of the functionalities of R, but this is to make you appreciate certain things that R can do. Perhaps in a later class, that will also depend on our course organizer, Munta. If Munta would want, we can have a proper workshop where we would go into all of these things one by one, so that we would have a better appreciation of that. Maybe by then we would have installed the software so that you can follow as I work, so that it will make it easier for you to appreciate. One of the advantages in R is also there are different types of variables in R. Okay, so when you are dealing with numbers, when you are dealing with letters, you can code all of these things in R, or you can tell R that this is a number, this is a letter, this is an integer, and then R will be able to recognize this so that you can perform a good analysis in R. So for any of us that have ever used SPSS before, in SPSS, you have to code your variables. If you are dealing with let's say a qualitative data, for instance, you are collecting data on preference of respondents to maybe sugar, and then you have a response of yes or no. You would have to code yes as 1, code no as 2, or yes as 0, no as 1. But in R, you don't have to do any code. You just have to tell R that this is a list of letters, or this is a list of factors where I have 2 levels, that is yes and no. And then R will recognize it. So anytime you run an analysis, the output will be given to you as, it will be able to recognize that this is a factor with 2 levels of yes and then no. You don't have to recode all your responses. So that is also one of the importance of R. So for instance, let me input a data. So initially I inputted a list of numbers between 1 to 10. So I'm going to assign that list of numbers variable in R. So I'm generating a list of numbers between 1 to 10, and then I'm assigning it to A. So anytime I call the variable A, it will give me a list of numbers between 1 to 10. Now I want to see the type of variable this A is. So there's a code, a function called structure, which is shortened as str, structure A, and then this tells me the type of variable. So from the output, we can see integer 1 to 10, 1. So it gives you the type of variable, and then also it gives you the output. So this is an integer. I can also type a list of letters, for instance. Let's say yes or no. So yes, and then no. Sorry. And then assign to B. So I tell R to store this as B. Anytime I call B, it should give me that output, yes and no. If I want to check the type of variable this B is, structure B, and then it gives me that this is a character. this is a character. So anything that is not numeric is recognized as character in R. But for the purpose of analysis, if I want R to recognize this as a factor with 2 levels, yes or no, I only have to change the variable type, which is also one of the functionalities in R. You can easily change from one variable type to the other, so that R will be able to recognize it when you are performing your analysis. So, for instance, I can change this B, and then sorry, I'm changing the data type from a character to a factor variable. So the function for doing that is as.factor, and then I have changed the B, which was initially a character, to factor. Let's now check the structure of B and then see what the output will be. So it's telling me that now B is a factor with 2 levels, no, and then yes. Okay, it is giving me that output now. Initially, it was recognizing B as a character, but now it is telling me that it is a factor. So you can change data types or variable types in R, and then you'd be able to work easily with R. So moving on, R also allows you to input data that you have recorded in Excel into the R environment to work with it. So you don't always have to enter data. If you are dealing with a large set of data, which you already have in R, you only have to call that data from wherever it is on your computer into R, and then you'll be able to work with it. So I have a data in my on my computer called compensation. Okay, so I've called this compensation file, and I have named it as data in R. So this is how the data looks like. It's a data of it's a 40 observations with the first column as fruit, the second column as fruit, the third column as grazing. So this gives you something like a spreadsheet where you can see your data as it was in Excel, and then you'll be able to check whether everything is okay with your data before you run any analysis. So feel free to save your data in Excel, but then R allows you to transfer this data easily into R to allow you to be able to work on it for your analysis. Now, aside the basic functionalities of R, there are packages and libraries that extend the functionality of R. Now, anytime you install your R, R comes with its own packages. So in the base R, there's some packages that were developed and attached to R when R was developed. So in my right bottom corner here, you have files, plots, packages, help, viewer, presentation. When I go to packages, it gives me a list of packages that are installed on this computer. The first time you install R or R Studio, you would have a number of packages over here. So these packages are what helps you to perform all the functions that you can perform in R. I would liken these packages as something like a recipe book. So if you want to prepare, for instance, you want to prepare Ghana jollof, for example, with a recipe book, you would know that you need to, first of all, get rice, you need to get oil, you need to get onions, you need to get the various ingredients that you will need. That is how the packages are. So within the packages, there are various functions that have been inbuilt in there. So whatever a task you want to perform in R, you only have to know that function and then call that function and then input the various arguments that you need within a function to perform the task that you want to perform. Yes, so packages help. So these packages are what helps us perform all the tasks that we want to do in R. But then the base R that was developed has limitations in the packages that it came with. So individual developers and then also the R core team that is dedicated for bringing up new things about R. They are always adding up new packages that extend the functionalities of R. So there are different packages that have been developed in recent times for using R. And then every day, new packages are coming up. Every day, new packages are coming up. So you don't have to be worried if you are a student or you are working in, let's say, in the ecological sciences, or you are a forensic scientist, or you are into finance, or you are into health. There's a package for everything that you want to do. There are packages for everything that you want to do. You just have to search, know the package that is appropriate, learn how to apply that package, and then easily perform that package in R. So, for example, if R has the function mean, so to calculate mean, R is able to do this in the base R. Okay, R is able to do this in the base R, but another function called deployer, as I have indicated here, deployer helps to perform certain manipulations on our data set that helps in the calculations of some of these things. So for example, in this data set that I called from my computer into R, I want to find the mean of this first column, the root. So I'll be able to do this by just typing mean, which is already a known function in R, and then tell R which data set I am working with. So the name of my data set, I've named it as data here in R. And then I tell R the column that I want to deal with. So the column is root. So once I enter this will give me the output, sorry. So if you can see this, just a minute. So you can see the output as mean as 7.18 of that column. But sometimes if you look at this data set, I have root, fruit, and then another column grazing, where the grazing contains two groups, ungrazed and then grazed. So sometimes you want to find the mean based on these two groupings that you have. Base R cannot do this, or the functionality in base R is limited. But then with deployer, I can manipulate my data so that it gives me the output, the mean for root, but it will group it according to the two levels of grazing. Okay, so deployer, for instance, I'll be able to group my means based on the grazed and then ungrazed. So just to demonstrate. So data, then I'm telling R to group my data by grazing, and then it should give me an output of my means. So so find the mean of root. Sorry, there's an error. I haven't called that function. So this deployer, for every package that you work with, you have to actually call that package before you can start working with it. Yeah, so because I didn't call that package, R did not recognize that function. So to call packages, you input library, and then you call that particular package. So now that I have called this package, it is still loading. Yes, I can now perform the task I initially wanted to. So you can see that this time the means have been grouped based on the 2 levels of grazing. So grazed 8.31, ungrazed 6.05. So packages help us to perform beautiful task in R as compared to the what we can do in base R. So for everything that you do, you certainly need 1 or 2 package. And to install the package, you just have to type a line of code, install.packages, and then you type in the name of the package you want to install in quotation marks. And then this will help you install whatever package that you need. So for every task that you want to perform, you just have to go into our search which package would I use, or go to Google, search which package would I need. Then you install that package, call that package using its library, then you perform that function. Another package I want to demonstrate is the ggplot2 package, which is a graphical package. It helps to produce very nice graphs in R. The functionality or the beauty of R's graphical abilities is a little bit limited, but ggplot helps to enhance these graphical abilities of R. So if you look at this data set, I have a column as root, fruit, and then grazing. I want to plot a scatter plot between root and fruit to observe the relationship. So what I can do here in base R is to indicate, so the function is plot, and then I indicate what should be on my x-axis. So I want root to be on my x-axis, and then fruit to be on my y-axis. And then the data that I need is called data. That is how I've stored my data in R. Object roots not found. Sorry. Just a minute. Yeah. Sorry, I'm encountering 1 or 2 errors. But I need to. Okay. So just a minute. Data. So with this, I have a scatter plot where my x-axis is the root, and then my y-axis is the fruit. And then this is base R to plot a scatter plot. But then let's look at how it looks like in ggplot. How it looks like in ggplot. So for ggplot, I have to indicate where my data is and then specify my axis. My x-axis is root, and then my y-axis is fruit. And then I want to plot a scatter plot. So jump point, and then I run this code. Sorry. Again, like I said, whatever package you want to use, you have to call the package first before you can use it. After installing, for me, I have installed it, so I don't have to go back to install the packages. I only have to go to library and then call that library. So after calling the library, I can now run my code. And then let's see the output. So if you look at the way this output is as compared to what base R is, certainly ggplot's output is better than base R. Okay, I can. It also has various things that I can add. Let me just use this thing, and then let's see how the output is. Just a minute. My laptop is refusing to display refusing to display my plot. Sorry about that. It's refusing to display the new plot I made. Sorry about that. But what I want to demonstrate is that gingerplot as a package helps to extend the graphical abilities of R. Okay, so what base R can do, gingerplot can do and do it better. Okay, so in gingerplot, you can edit your x-axis, y-axis. You can even change the colors of your point. You can change the colors of your point. So, for example, let me change these points into blue instead of black, and then let's see how it would look like. Yes. So instead of the points being black, this is giving me as blue. So you can change so many things about your graph using gingerplot, and it helps to extend the functionality of R. So that is also one of the things that R can do. Let me just add one demonstration of box plot. So this time, I want to plot the root values, but I want to show a box plot where based on the grazing. Okay, so in base R, I will do this by typing box plot, and then I specify my x-axis, which is supposed to be grazing, and then my y-axis, which is root. So I run this, sorry, from numeric argument to binary. Sorry. Okay, so I need to change my grazing to factor before it would work. So just a minute. Later. Yes, so let me now plot this box plot and see. Yes, so this is how the output looks like in base R. But then let's do this in gingerplot and see how the differences are. So gingerplot, our data set is from data axis. We have X as grazing, and then Y as root. Then we add another layer. This time, box plot. Yes, and then let's run this and then see. So this is the output for gingerplot 2. So gingerplot's output certainly is much more nicer or better than what you would have in base R. And then you can make so many edits with gingenplot too. So I want to change the color of the lines of the plot to blue, for instance, and then change the fill, the colors within the boxes to say yellow. And then let's see what the output would be. So yes. So you can change the text styles, you can make annotations on the graphs. You can do so many things with gingenplot by just adding up layers with a plus sign. So after every line of code, whichever layer you want to add, you just add plus, then you add that code for what you want to do on your plot. So packages and packages help to extend the functionality of R, which is one of the various usefulness of R. So as a result, you can use R for so many kinds of analysis. For me as an ecologist, I always need to calculate data on my species richness, species diversity, species abundance. I need to plot some metric curves and all of that. I can do this with a package called Vegan. For those that are interested in spatial analysis, you want to look at maybe land use change. You want to perform certain analysis on using coordinates or using graphs or maps of various study areas that you've done. You can do all of these things in R. You want to do modeling in R, it's possible. So everything that you want to do in R, it is possible. You just have to know which package you need to install and then which functions in those package you need to perform the function that you want to. And then easy peasy, you are able to perform every task as much as possible. So R has over 10,000 packages, so many of them, and the new ones keep on coming. New ones keep on being added to the packages of R, which help to extend the functionality of R. So I would like to end here, and then thank you very much for the opportunity that has been given. Like I initially said, this is only an introductory lecture to get you interested into R and then to expose you to some of the functionalities of R. If we have the opportunity to organize a proper workshop, then we can go into some of these functionalities step by step for you to appreciate how you can use R for the various tasks that you intend to. If you have interest in academic research, you have interest in industry, in finance, in forensic science, wherever field that you want to find yourself, there's a package for you. There are resources for you to learn, to be able to apply R in those areas. So yes, so thank you very much. And then I would leave the mic to Munta now, just in case there are any questions, so that I'll be able to answer them. Thank you very much.
Thank you very much, Ike. This was a very amazing lecture. Even though halfway through the course, I noticed that we'll really need like an in-depth workshop along, maybe hopefully sometime, because
certainly,
even with my little exposure, I got a bit lost. It was so difficult for me to understand what you were doing within the R interface. Sorry, the
okay.
R Studio.
Okay.
So if you, I just have one question. Can you open the R Studio interface?
Okay, just a minute. Yeah. Yeah, it's opened.
Yeah. So at the beginning, you were working at, I think that was the console, right?
Yes, I was working in the console
That was where you were doing your calculation before you moved to work on the
to the
window
script.
above the console. Yeah.
Exactly,
That one is called
exactly.
the script. That is the
Yes,
script.
please.
Then below it is
Yes,
the console. So
yes, please.
anything that you can do in the console, you can do the same too in the script. Like
Yes,
those kind of basic arithmetic you were doing calculations, 1 plus 1, all those things.
yes. You can do. You can also do in the script, but the script helps you to save the the codes. In the console, you can't save it. The console is just for
Okay.
output, so you can't save. If you write in console, you will lose some of your codes, or you will
Codes.
not be able to
Okay.
repeat it
Okay.
the next time. But then if you write in the script, it's easy to reuse it at another time. Mhm.
Okay. Okay. So under what conditions would it be advisable to write your code in the console instead of the script?
Always write in the script. Always write in the script. So you write in the script and then you run to see the output in the console. That's always write in the script and save your script
Okay.
so that you'll be able to use it the next time you are working in the script. Yeah.
Okay. So in case I want to be stubborn and I still write, let's say a graph, maybe a code for to display a graph in the console,
Yeah. Yeah.
will it still give me the same kind of
Oh
visualization
yes,
as
you will get the
writing in the
output.
script?
You will get the output. You get the
Okay.
output. So let me copy this code and then paste it in the console and then run from the console. You will get the output.
You get the output.
You
Okay.
get the output,
But
but you can't save this line of code from the console. So you have to write in
okay.
the script so that when you close RStudio, the next time you are working in RStudio, you can reopen that same script. It's like a Word document. So you save the Word document, then the next time you want to work with it, you open it to work.
And
So
continue.
that's
Okay.
how it is.
Okay. I think I was able to grasp a lot, and then a lot to also just pass through like that. I was not able to
Sorry
get the
about that.
concept. Yeah, yeah.
Myself,
But it's
I can see that the number we started with has declined
yeah,
a
yeah,
bit.
yeah, yeah, yeah.
Perhaps somewhere in the middle, it was a little
A
bit.
bit difficult, yeah.
Yeah, I understand. I
But
understand.
anyways, programming, if it's not difficult, then anyone can
Yeah,
just do it.
yeah,
But
yeah.
as you
So,
just said,
like
when you put the
I said in the slide, the initial stages is challenging, but once you build on it, and then if you don't give up at the beginning, you are likely to go very far. But then if you give up just on the first day, on the second day, it's difficult to pick it up again. Yeah.
again, okay, okay. Then we really like to have you here for a workshop where we all have the software installed. Then maybe you can
Certainly.
even give us some data recommendations and some packages to install, so that we can work
Sure,
alongside
sure,
with you whilst you are doing that. We can be practicing,
sure.
so that we
Exactly,
can really get
exactly, exactly.
the experience that we
That
need.
would
Yeah,
be better. That would be
yeah.
better.
So
Certainly, that would
hopefully
be
we'll
better.
plan that in chambers, and we can bring it out on board to let the people know when we decide.
Okay.
Okay, so I think that is all the queries that I had. So if any of our audience would also like to have ask you any question, I think the floor is open.
Okay.
We have Ben
Okay.
Cash, Antonio, A- Anyim, right? Something like Anyim. Sorry if I killed your name.
Yeah.
And there's a
And
name or a participant here. I cannot pronounce the name. Yeah.
it's
So
Eric.
please, if someone wants to ask any question or needs any clarification, the floor is open. Okay. This is silence means consent, right?
Okay, there's a
Okay, so
hand
Enzula,
raised.
please, yeah, yeah, you can ask your question, please.
Yes, thank you for the opportunity. I joined late, but your late question made me got one or two things. Please, I want to know the versatility of R and that of Python. appears, though I'm not too, let me say I'm a beginner with R.
Okay.
But it appears the interface is almost like that of Python.
Okay.
So comparing Python and R, which one is more better to use?
Okay, so it depends on what you want to use the two languages for. If you want to do more of statistics, statistical analysis, data visualizations, computations, then R is the best. But if you want to go into more of data science, data modeling, machine learning models, and those stuff, for those ones, I'll recommend Python for you. But from my experience, I would say that starting with R is easier to progress to Python than starting with Python as your first language. There are so many similarities in the two languages. So once you build a strong basis in R, it's easier to progress to Python, in my opinion. Yeah. Okay.
Yeah.
Okay. Thank you.
You can still continue. Okay.
Thank you. Thank you.
Okay. Yeah. Welcome.
So, any further clarification from our audience? It seems we are all clear. Yeah. So, without much further ado, I would like to thank you so much for your time. I appreciate your enthusiasm, your zeal, and the energy you kept into preparing this whole course. Like, I can see a lot of effort in it, and I really appreciate it. Thank you so much. And our audience that stayed with us from the very beginning till the end. Yeah, thank you very much for staying with us.
Thank you.
We shall keep you posted with new updates regarding any further lecture or tutorial. If possible, a workshop, we shall organize one.
All right.
In no time.
That's it.
All right. So
that's it.
Okay. So have a great day, all of you. Thank you so much.
Thank you too.
Okay.
Thank you
signing.
For the opportunity.
Okay. It's a pleasure, bro. It's a pleasure. Okay. So signing out. Bye.